So now in this video, we're going to look at the 555 timer in bistable mode right now. And so you can see here, we have the output. The output's actually high right now, and so close to the positive rail, but it is a ways away. But in any case, that's topics for other videos. It's trying to get to the positive rail until I hit that button. Now the output's trying to go to the negative rail, and it's actually doing a pretty good job there. And so it's going to stay like this until I hit that button. And so it has two stable states. It's stable right there. It's not going to change until it gets a signal telling it to change. And now it changed, and I can keep hitting that, don't matter. It's going to stay in that position until I give it another signal over there. So I'm going to quickly just kind of tear this apart a little bit. It's actually a pretty simple circuit, and most of the circuitry is jumpers I have on the board. So we will pluck these and reconnect them as we build the circuit. So as you can see here, we have to power the integrated circuit. So that's what pin number 8 and pin number 1 are doing. You can see that right there. Pin number 8 is the positive side of the power supply, and so that's the top right pin over there. It goes 1, 2, 3, 4, 5, 6, 7, 8. Positive side of the power supply. Pin number 1 to the negative side of the power supply. That jumper is going over that row right there. It's connected to pin number 2. That goes to pin 1. So that does a couple things. It powers the integrated circuit to do all the things it does. It outputs either close to the positive rail right there, or pretty much directly to the negative rail right there. One or the other. And that's why the LEDs were changing light. Now, we also have pin number 6 right there, connected directly to the positive rail. That is the threshold pin. So that is waiting, it's going to the negative rail. I think I said positive. That is waiting for a positive signal, and by putting it to the negative rail, that prevents it from ever getting a positive signal. It's directly to the negative rail. It's telling it not to do anything, but that's important so that it doesn't pick up stray signals. Now, we have, for the next two pins, that will be the trigger and the reset. So these are the two most influential pins for this circuit. You saw when we pressed one switch, the output went high, and when we pressed the other switch, the output went low. So when it went high, that was the set pin, which is going to the trigger input right there, the trigger pin. And so we have a switch here, as you can see, that goes to the negative rail. It is waiting for a low signal to do something. That's why we have that switch separating it from the negative rail. Now, to prevent it from getting stray signals, remember we were talking about that with pin number 5, we're going to take a 10 kiloohm resistor. That value doesn't matter, but you just want to make sure it's low enough you don't get stray signals. So that's going to the switch. We could also just put it right there. Doesn't matter, it's the same node. That is connecting like that to that side of that jumper is electrically just like connecting to that side of the jumper. Does not matter. So we have a direct connection to the positive rail. I mean, it's through a resistor, but right now, if the power is on, I'm going to turn the power off. When the power was on, we did have 5 volts at that pin, but it was through a resistor. So if we close that switch, that gives us a direct connection to the negative rail, which way overpowers whatever that resistor is doing. And so pin number 2 is waiting for a low signal, as is pin number 4. So pin number 4 is the reset. Same thing. So you can see we got that jumper going to this side of the switch. It separates pin 4 from the negative rail. And again, we're going to hold up the voltage with a 10 kiloohm resistor right there. And that's literally all it's doing. It's holding 5 volts there until we close the switch, which gives a direct connection to the negative rail. So whatever this resistor is doing has no impact. We have a direct connection as far as pin number 4, the reset pin, is concerned. So that is it for wiring a flip-flop. But now we're going to give it a load where we can see it doing something. So we have the LEDs there. So that's pin 3, the output pin. So right there, output pin. And with this breadboard, it's really nice. I have another little breadboard area next to it. And so this white jumper goes across there. And so this whole row now connects to the output right there. And so I got a couple LEDs here. You could use the same color, or you could just get rid of that one, or just get rid of that one, however you want to do it. So I want to wire the green. This is green. It says maybe blue on there, but I'm going to use green to indicate that the output has a low signal. So the short lead, the cathode, is going to go to the output because I want it to light up when it's low at the output there. That means first I'm going to take a 220 ohm resistor, as you see there. I also have 1K written there. We'll look at why coming up. But this is going to go to the positive rail. So I'm going to use 5 volts. And that goes between the long lead, the anode of the LED, and the positive side of the power supply. And so that means the green LED will light up when the output goes low. So I just turned the power on, and now the output's high. Now the output is low. I'll turn the power back off. So we could just use that, or we could just use this one, or both, this the red one and the green one. So red one is opposite. We're going to take the long lead, the anode. That's how you know the anode side of the schematic symbol. Put that directly to the output. And so now, if we put a resistor to the cathode and then to the negative rail, it will light up when the output is high, right there. And so that's now starting to kind of block things, and so that's why I wired that last. Right there, we're done. I got the power on, so the output is normally low, it looks like. Looks like it prefers that. And I think it was that button I had to press. And, oh, I went to the wrong spot. I put that resistor to the positive rail. There we go, negative rail. First thing, when a circuit doesn't work, check your wiring. Make sure your wiring is in the right spot. So, now, we have the flip-flop. So, let's talk about a few other things. First off, this power supply right here. So, I think right now we are in the condition we want to be. If I bump this, you can see that the output changed. So that gave us a spike or something at the rail and threw things off a little bit. And I don't have to bump it very hard. I was doing this accidentally, just moving it around right there. I didn't have to do it very hard. So 100 microfarad capacitor here. I'm not sure the exact value you need to use. I don't think it has to be terribly large, but this works pretty good. I'll just put it at the rail. And now the power that the supply here is giving the board, if there's spikes or something, it takes a bit of time for the capacitor to charge or discharge. Right now it's just charged to 5 volts and holding it there. And so you can see that I can bang this around now. We're not having that problem. So problem fixed there. The other thing is pin number 5 right there. So that changes the voltages that some of the internal parts of the 555 timer respond to. And I haven't had a problem in the vast majority of my videos. I finally found one where I needed it. But this is, I'm going to put it to the negative rail. You see this a lot in circuits. I think I give it a false signal. That's why it changed. But you see this, it's a 10 nanofarad. Usually you see 10 nanofarad, which is the same as 0.01 microfarad. Same value. That's what you usually see there. Again, exact value doesn't matter. That just charges it, and just different little stray signals or something, it absorbs that, prevents the voltage from changing. Holds it steady. And so basically, again, it basically tells that pin not to do anything. Now, The pull-up resistors. So, as we said before, we need a low signal, and you actually need a low signal. So why do you got to hold it high? We'll talk about that. So first off, I'll kind of do a little sweep around here, and you see nothing changes. These kind of come loose, and so things may change. I actually pressed that button by accident, but there you can see nothing's happening. If I get rid of these resistors, the pull-up resistors, now when I sweep, actually we're doing pretty good on straight signals there. Usually it was bouncing, so let's pull that one. And I'm actually surprised we're not getting, oops, that started popping off. Now let's pull that one. There we go. We finally have a problem with stray signals. So again, you may get away without them with no problem, and looks like you're a lot better off with that smoothing capacitor to the rail. But now that that's gone, as is the capacitor to pin number 5, so they all help for stability. Now I can swipe along here all I want, and we have no problem. But again, we still have that problem. I just touched the power supply, and the output changed right there. So this smoothing capacitor's pretty important for a practical circuit when you're just doing your demonstration circuits, your prototyping and whatnot. You may get away without these capacitors all you want, but just be aware you may need them. But while you're learning about them, it's just kind of a couple more components to confuse you a little bit, but they are important for practical circuits. So in any case, hope you enjoyed the video. Here is the circuit in full without the other capacitors. So again, a lot of times with your power supply, they may not talk about the smoothing capacitors. A lot of times you will see a capacitor between pin 8 and pin 1 to remind you to use one of those. And but normally people just kind of draw a schematic like this. They usually show the pin 6 though, or pin 5, the control voltage capacitor. But they don't always show that, but it's a good idea to always include that. Also, while I'm doing my demonstration circuits, it gets in the way a little bit, so I just omit it. But it is good to have that capacitor there. So, in any case, thanks for watching. I will see you in the next video.